Let's start with the first one. Right? So we have cosec A. Now, please pay attention. We have cosec A. Cosec is the reciprocal for sine. Okay? So we have got that in that. Okay? So if I want to write cosec A, I can write it as, this is A, it will be cosec A, which is this angle. Obviously, this becomes the opposite side, and that's the adjacent side, and this is the hypotenuse. Okay, so the way you identify the hypotenuse, adjacent, opposite side does not change. Okay, it's still the same way. You identify your reference angle, then use the reference angle to determine the opposite side. The third side will be the adjacent side. So cosec A, based on this, it's equal to the hypotenuse divided by the opposite side. So here I'll write here H over O. For our question, our H is going to be AC. And our opposite side is BC. So that's it. Okay? So that's the first part. Then cosec C, okay? Our reference angle has changed. So we need to change as well the naming of the sides. That color doesn't want to be chosen. Okay? So we now have C, not A. So C is that. So this becomes the opposite side, and that becomes the adjacent side. The hypotenuse doesn't change. Okay? The hypotenuse doesn't change. So cosec C is still hypotenuse over opposite side. The hypotenuse is still AC, but the opposite side has changed now. It's now AB. Okay? Then the third one. The good thing is my triangle is now labeled, because it's mainly based on angle A and C. B is a right angle, so we don't use it. Then sec A, okay, our reference angle is now that. So sec A is this one here. Is the hypotenuse over the adjacent side. So it will be H over A. Our hypotenuse is AC. Our adjacent side is AB. Okay? I'm sure you can see that there's a relationship between cosec C and sec A. They give you the same ratio. Okay? Cosec C and sec A, they give you the same ratio. I told you about this last time that it's mainly because of the relationship between sine and cos. But we don't talk about that relationship at this stage, in this grade. Okay? So we have got sec A. Now sec C. So sec C is still hypotenuse over adjacent. But the adjacent side changes. Okay? It's no longer AB. The hypotenuse still remains AC. The adjacent side with reference to angle C is now BC. And I'm sure you can see that sec C and cosec A, they are equal. Okay? Are you following? Yeah, sir. Let's move on to E now. Cot. The reciprocal for tan. Okay? The reciprocal for tan. So I have to go to the next page. So E, we have cot A. Cot A is equal to adjacent over opposite. Okay? Our reference angle is A, which is this one here. That's the opposite side, that's the adjacent side. So we are going to divide the adjacent side by the opposite side will be AB over BC. So this will be AB over BC. Please, when you're working with reciprocals, make sure you're very, very careful. Because it's very easy to make a mistake. Make sure you're very careful. Then F, it's cot C. Cot C is also A over O. But both the adjacent and the opposite are going to be different as compared to when the reference angle is A. So cot C is that, this is the opposite side, that's the adjacent, so it will be BC over AB. It is actually the reciprocal of the ratio of cot A. So it will be BC over AB. So what I have here, you swap the numerator and the denominator. Now if you practice, you're going to pick it up that there is some relationship. Okay? So this is the exercise. Now, I'm going to bring in a triangle now, okay, such that we can calculate the length using the reciprocals. To create a question. Okay, first thing, let's find M and N. Okay, let's find M and N. Right, to find M and N, I'll just write here example. This is a numerical one. Okay, we need to find M and then we need to determine N. Okay, now I'm going to use trig ratios. Okay, then I'll incorporate the reciprocals. Okay, so first thing, let's find M and N. To find M and N, I need to determine M first. Okay, so I'll identify my triangle as in triangle BCD. In triangle BCD, okay, always when you have more than one triangle, you must identify and name the triangle you are going to use. So in triangle BCD, this is my opposite side with reference angle C, and sorry, that's my hypotenuse. This is the hypotenuse, that's the opposite side, and this becomes the adjacent side. Okay, so I want to calculate the opposite side. The hypotenuse is given. So among the three ratios, which one can I use then? If you have got the opposite, if you don't have the opposite side, you have the hypotenuse and you have got a reference angle. Which trigonometric ratio can you use? Huh? Am I talking to myself now? We have the hypotenuse, we have a reference angle. We want to calculate the opposite side. Which ratio can we use? No. Use sine. Okay? We use sine because we don't know the opposite side, but we are given the hypotenuse and the reference angle. So we use sine. So the first thing here is to say sine, here it will be sine C is equal to the opposite side divided by the hypotenuse. Right? Generally, you get a mark for knowing which ratio you are supposed to use. So this becomes sine 70 is equal to the opposite side is M, the adjacent, sorry, the hypotenuse is 17,8. Okay? I hope you are following me. Then you divide that sine 70 by 1, you cross multiply, you get 17,8 sine 70 degrees is equal to m. Then you use your calculator. Okay? Bring your calculator in. Okay? This is 17,8 times, okay, that would be times sine 70. Okay, close the bracket there, and then you get that. So let's round it off to 2 decimal places. Okay, that will be 16,73 to 2 decimal places. Okay, so it means m is going to be 16,73. So I'll write here m is equal to 16,73.
So do we say units or do we just do
Yeah, you should put units here because it's a because you're not using your calculator properly. Alright? So we have got that. We have m now. Okay? We now need to determine what n is. Okay? Now to calculate n, there is more than one way of doing it. Okay? There is more than one way. Now, I did an example where I used a line, the length of a line inside. Now this time I'm going to do it the other way. I'm going to identify triangle ACD. For triangle ACD, AC is the hypotenuse.
Sir, how is it 73 units?
16.
Okay. Alright, so I'm going to identify triangle. I'll say in triangle ACD. Okay? In triangle ACD. Make sure you pay attention carefully. Let me use that color. It doesn't want to be chosen. So I'll try that one. Okay, in triangle ACD, this is going to be my reference angle, so that will be the opposite side. Okay, remember, angle D is 90. Okay, so this becomes the hypotenuse. The whole length AC is the hypotenuse. So if I want to get N, okay, I can calculate, in fact, here I can calculate that opposite side. Then I'm going to use the theorem of Pythagoras to get that AB, which is equal to N. But that's not the only way. I can calculate the size of this angle and straight away use that reference angle together with M to get AB in triangle ABD.
Okay, read ACD.
So there is more than one way of doing the question. Yes?
So because the 90 degree at used because the second, can we state that equals to 45 degrees?
No, no. You can only do that if the question says that AD is equal to CD. If you are not told, or if it's not indicated on the diagram, don't make an assumption. Okay? So angle D is not bisected by BD. Okay? Right. So there's more than one way of doing the question. Okay, so you can approach it based on the idea which comes into your mind when you first see the question. Okay, no one should tell you that you should approach it this way. No, as long as the question, as long as you are using the correct mathematical concepts, then it's fine. Okay, so okay, I'm realizing now that it's better for me to use triangle ABD, so I'm going to change that. Okay, I'll change this to ABD. Okay? But in triangle ABD, I need to find the size of angle A. So what I'm going to say is angle A is equal to 180 minus 90 degrees plus 70 degrees. And that will give me 20 degrees. Because 70 plus 90, that's 160, so you get 20 degrees. Please, you must write the reason here, sum of angles in a triangle. Okay? Right? So this angle is 20. Once you know that angle, it becomes a piece of cake. Because when you identify your side, otherwise this color doesn't want to be chosen. So with reference to angle A, BD becomes the opposite side. And AB, which is N, becomes your adjacent side. And obviously this side becomes your hypotenuse.
So how can you use the 70 if it's not in that triangle?
Huh?
How can you use the 70 if it's not in that triangle?
Okay, that will be a very long method. You have you have to find BC.
No, but I mean, how did you use the 70 there if it's not in triangle ABC?
Okay, if you look at the bigger triangle ACD, this angle here, it's part of ACD. Oh, I wrote A. No, okay.
The angle won't change.
Alright. Remember, angle A is a common angle. Angle A is a what? It's a common angle. Don't forget that. Angle A is a common angle. So if you write in triangle ACD or ABD, if you want to calculate A, you find what I wrote. Because angle A is common to two triangles, ACD and ABD. Okay?
I don't get it.
Are you following?
No. I'm following.
Okay, so you can use the 90 at D and the 70 at C to work out A.
I want to calculate this
But
angle.
then so C isn't a part of ABD though.
Okay, wait. I want to calculate that angle.
Yeah.
Right? Because this angle here is a common angle to two triangles, ABD and ACD. I wrote it as in triangle ABD, then I calculate A. It's fine. Because the objective there is to calculate angle A. Okay? That's the objective. Okay? If you want me to change, I can change too. Okay? It won't make a big difference because of the fact that it's a common angle. Okay? So I can make that my C as well. It will still remain 20 degrees. Okay? Then, when I want to calculate N now, I'm going to bring in triangle ABD. Okay, I did that to avoid unnecessary confusion. So in triangle ABD, okay, I've identified my opposite side, adjacent, hypotenuse. So it's going to be opposite over what? It will be opposite over the adjacent. So we have to use what? Tan. Okay? So here I'll write here tan. It will be tan A. Okay? Tan A is equal to the opposite over the adjacent. My tan A is 20 degrees. My opposite side is M. But M is equal to 16,73 units. Now I suggest that we use the original one which was not rounded off. Okay? I think we've got that on the calculator. I think it's still there. That's the original one. That's the one that I'm going to use, okay? So, I'll just write it as 16,72 dot 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 all over. Okay? All over what? All over AB, which is equal to N. Are you following?
Yeah.
Then you divide here by 1, cross multiply. If you do that, you get N tan 20 degrees is equal to 16,72 dot dot dot. Right? The reason why I'm putting the dot dot because It's because we want to use the original value of m, which is not rounded off. Okay? Then, by now, all of you must know that this becomes n equal to 16,72 over tan 20 degrees. Okay? Now, let's put that in the calculator. The good thing is we already have that 16,7 something, so we just divide this by tan 20. Okay? So you end up getting 49,96 to 2 decimal places. Okay? 49,96. So n is going to be 49,96.
So,
Yes.
when you're doing that, do you have to use like the whole decimals that are in your calculator?
Yeah, because you see, we are taking the.
When I use 16.73, I got 25.94. So if you try to include all the decimals, we get it wrong.
Okay, generally, as teachers will end up giving you a benefit of the doubt, but if a memo in a test or examination is strict, you can be penalized.
So you just have to use.
So it's better to use the original value before rounding off. Okay, you can only do that if you are using the previous answer from the previous question. Okay? But I want you to be aware that this is not the only way of getting n. Okay? This is not the only way of getting n. You can also get n by finding BC, then you find AC. Okay?
Divided by 2.
Which two are you talking about?
You bring up the what we just did with
That's tan.
This is tan 20 degrees.
yeah, so you divide by 20.
No, that's like 10.
Right? So this is not the only way. You can also find BC and then find AC and then subtract BC from AC. That's a longer way. Okay? That's a longer way. So this will be the shortest way of doing the problem. But you need to get the size of angle A first. Like, I want you to know that when you are doing these questions, whatever idea comes into your mind, which is mathematically correct, use that method. Sometimes it can be short, sometimes it can be a long method. But both cases will give you the same answer. Okay? So I'm done here. Now let me bring the. Okay? So if you got your calculator, you press the fraction option. I hope, but before I carry on, do you understand what I'm trying to do?
Yes.
So if I divide 1 by tan 20, okay, I'm getting that 2,75. Okay, which means everything that I did here was right. Okay, so these questions you can even verify if your answers are right. There is a clue somewhere in the question that your answer is right if you did it properly. Okay, let's do another one. Let's try to do say sec. Okay, sec C. Okay, sec C. All right, sec C. It will depend now which triangle you want to use. Okay? Remember, sec is always equal to, we divide the hypotenuse by the adjacent. Okay? We divide the hypotenuse by the adjacent. So let's check, based on the information we got, what we have. Right? And we need to know which triangle we are going to use. Now, in this case, we have the hypotenuse. For triangle BCD, we have a hypotenuse. Okay? For triangle ACD, we don't have the hypotenuse. Remember, angle C is a common angle to two triangles, BCD and ACD. Right? But in ACD, we don't have the hypotenuse. For BCD with a hypotenuse plus we don't have the adjacent side. but we have got the opposite side. Okay? What that means is, if I'm going to use triangle BCD to calculate sec C, it means I need to find the length of BC. Then you can use the theorem of what? Pythagoras. You can also use trig ratios. Okay? I'm going to use the trig ratios. Okay? So this is the adjacent side. I've got a hypotenuse. So I can use what? Cos among the three trig ratios. I'm going to use cos to get BC. Then after getting BC, I'll find sec C.
Sexy.
Okay? What? You're starting to have a, what can I say, a dirty mind now.
No.
Right? So that's in triangle BCD. So I'm going to carry on later. So I'll say in triangle BCD, okay, cos C is going to be equal to the adjacent over the hypotenuse. So in this case, what am I trying to find? Okay, I'm trying to find the adjacent side. Okay, so my adjacent side, I hope you can agree with me that I can just multiply this h by the cos C. Right? So you get 17,8, okay, times cos 70 degrees. What does that give you? Okay, I've got my calculator here. Let me do it whilst you are doing it too. So it will be 17,8 times cos 70. Okay, so you get 6,09. Okay, let's round up two decimal places. 6,09. Right. Well, there's a 7 here. So 6,09. So that's 6,09 units. Okay? 6,09 units. Are you following? Yeah? So I found my adjacent side. This adjacent side is equivalent to BC. Okay? So my BC is, please don't confuse this A that I wrote. In actual fact, let me remove that A to avoid confusion. This is what? BC. Okay? That's BC. Once I find my BC, then I can determine what sec C is. Now, sec C, so sec C is equal to hypotenuse over the adjacent. So that's equal to, now check this. Do you see that here cosec C is equal to A over H? Sec C is equal to H over A. So we are just dividing the hypotenuse by the adjacent side, but we didn't have the adjacent side, so I had to calculate it. Okay? So it becomes 17,8 divided by, this is 17. This is 17,8 divided by 6,09. (6,09). So that's sec 70. So when you simplify this, we get sec 70 is equal to, that's 17,8 divided by 6,09. You get that. That's 2,922 recurring. So let's just call it 2,9. Okay? So that will be 2,9. To or you can put 2,9 to two decimal places. So this is gonna be 2,9. Okay, let me leave it as one decimal place. It won't make a big difference.
Yes, sir.
Okay. Now you can check with your calculator if sec 70 is equal to 2,9. You just divide 1 by cos 70. Okay, you can divide 1. You are supposed to just to check your answer.